Hi, my name is Awaidina bin Shahriel.
Hi, my name is Jabatrisha binti Sharizai,
Hi, my name is Natasha Husna binti Yahya.
We are from
Faculty of
Civil Engineering. Differentiation is the process of finding the derivative of a function.
What is the technique of differentiation? Start with constant, we see f(x) equals to c. When we drive, that is become 0. It's a constant value. And then we go to linear, is ax plus b. Only the a variable is left. Now y is b equals to 0. And ax, when we drive, that is become a. So now let's move to the power. Power, we can see x power of n. When we drive, that is become nx power of n minus 1. Where we see here, the power is brought up front and multiply with x. Y is also subtract the power with 1 as we see.
Okay, so one of the technique of differentiation is product rule. Here you can see the function is u multiplied to v. So here we have two formula, which is dy over dx equal u dv over dx plus du over dx. Or we have f prime equal u v prime plus v u prime. But most of students will choose this formula because it's easier to understand. So here I will give one example to make you guys more understand. So here the example of product rules. So this one gonna be u and this one gonna be v. So we rewrite it below. U equal to 5x plus 3 and u prime gonna be 5. So v equal to 3x power of 2 plus x and v prime gonna be 6x plus 1. So after that we put it into a formula which is u v prime plus v u prime, and it will look like this. So you guys just simplify it and get the answer. The second one is question rule. So you can see here the function is fx equal to u over v. So here also we have two formula, which is dy dx equal v du over dx minus u dv over dx over v power of 2. Also we have f prime v u prime minus u v prime over v power of 2. Same one as product rule. Most of students will use this formula because it's easier to understand. This is example for question rule, and this one gonna be u and this one gonna be v. So for u prime will be 2x and v prime gonna be 4. We use this formula and put this into a formula. It will look like this, and simplify and you get the answer. This chain rule we use to differentiate composite function. If y equal f gx, it will be dy dx equal f prime gx plus g prime x. So we use chain rule when function inside another function. See, you will see function inside another function. It allows us to differentiate complex expression easily. So to make you guys understand, I will give some example. So here the example of chain rule. First, we need to identify the outer function and inner function. Okay, this one gonna be number 1 function to simplify, and this one gonna be number 2, and this one gonna be number 3. Okay, we simplify one by one. So the function go to here, and it will be 2 sine 6x, and this sin 6x will be cos 6x, and 6x will be 6. And we simplify, we got the answer.
For the question number 2, differentiate the following function with respect to x. Question A, fx equals 2x ln sin 3x. So we need to use product rule and chain rule. Okay, first step, we need to identify the structure of the function. Here we have a product of two functions, 2x and ln sin 3x. So we will use the product rule, which is dy dx equals uv prime plus vu prime. Okay, find the derivative of 2x, which is 2. Now find the derivative of ln sin 3x. This requires the chain rule. The derivative of ln u is 1 over u, and derivative of sin v is cos v times v prime. So derivative of ln sin 3x is 1 over sin 3 times cos 3x times 3. equals 3 cos 3x over sin 3x equals 3 cos 3x. Now, last step, we need to apply the product rule, dy dx. dy dx, 2x times 3 cos 3x plus ln sin 3x times 2. The final answer is 6x cos 3x plus 2 ln sin 3x. Okay, for the question B, fx equals exponent power of 5x times ln 3x. Okay, first we need to recall the product rule and chain rule. We need to use them. Okay, the next step is we need to identify u and v. Let's u is exponent power of 5x and v is ln 3x. Okay, after that we need to find the derivative of u and v. U prime equals 5 exponent power of 5x and v prime equals 1 over 3x times 3 equals 1 over x. The last step, we need to apply the product rule. dy over dx equals uv prime plus v u prime equals 5 exponent power of 5x times ln 3x plus exponent power of 5x times 1 over x. The final answer is 5 exponent power of 5x ln 3x plus exponent power of 5x over x.
So I will show you how to solve this question. So the first one is we need to differentiate both sides with respect to x. So we start with the right side first. So we know that if we differentiate 5, we will get 0. So dy over dx, 5 equal to 0. So next, we need to differentiate each term on the left. So for the left side, we start with the x power of 3y. So for this derivative, we use product rule. So for the product rule, we need to separate term by term. So this one is u, this one is v. So we know that for the formula of product rule is dy over dx equal to uv prime plus vu prime. So u equal to x power of 3. If we differentiate x power of 3, so we will get u prime equal to 3x power of 2. So for the v equal to y, if we differentiate y, so we will get v prime equal to dy over dx. So now we can use the formula of product rule equal to x power of 3. V prime is dy over dx plus v is y multiplied by u prime is 3x power of 2. So dy over dx is the final answer. Okay, for the second one is we need to use two rules, which is chain rule and product rule. Okay, so first we use chain rule for cos 2xy. If we differentiate cos, we will get negative sign. So cos 2xy equal to negative sign 2xy. So the second one, we use product rule for 2xy. By the way, cos 2xy is a constant. So 2xy, so we need to just spread term by term. So 2x is u and y is v. So for the formula for product rule is dy over dx equal to uv prime plus vu prime. So u equal to 2x and u prime equal to 2, v equal to y, v prime equal to dy over dx. Now we need to use the formula dy over dx equal to u is 2x, v prime is dy over dx plus v is y, u prime is 2. So the next step, we need to factorize. So dy over dx equal to 2x multiplied by dy over dx plus y. Okay, next we need to combine chain rule and product rule. So dy over dx equal to negative sign 2xy multiplied by 2x dy over dx plus y. This is the final answer. For x cos y, we use product rule. So we need to separate term by term. So x is u, cos y is v. So we know the formula for product rule is dy over dx equal to uv prime, uv prime plus vu prime. So u equal to x, u prime equal to 1 and v equal to cos y, v prime equal to negative sign y multiplied by dy over dx. Okay, so we can use the formula dy over dx equal to u is x and v prime is negative sign y, dy over dx plus v is cos y, u prime is 1. Okay, for step 3, we need to combine all the derivative. So 3x power of 2y plus x power of 3 dy over dx minus 2 sine 2xy multiplied by 2 dy over dx plus y plus cos y minus x sin y dy over dx equal to 0. For step 4, we need to factorize dy over dx. So dy over dx is the subject multiplied by x power of 3 negative 2x sine 2xy negative x sine y dy over dx plus 3x power of 2 minus y minus 2y sine 2xy plus cos y equal to 0. So this. Okay, for the last step, which is step 5, we need to let dy over dx as a subject. So dy over dx equal to 2y sine 2yx minus 3x power of 2y minus cos y over x power of 3 minus 2x sine multiplied by 2xy minus x sin y. So this is the final answer. Bye.
Question 4, we use linear approximation to estimate the value of cert for 15.99 plus 1 over cert 15.99. The answer must be 4 decimal places. So step 1, we change 15.99 the value to x. So it will look like this. And to make me easier to differentiate, we make it x power of 1 over 4 plus x power of negative 1 over 2. So differentiate and we get this answer. So the given value is 15.99. X naught will be the chosen value. So the chosen value must be the closer from given value, so which is 60. Step 2, x minus x naught, and we will get minus 0.01. Step 3, we use this formula and we get this answer. And remember, we need to 4 these decimal places. Thank you.
In conclusion, differentiation is a fundamental concept used to determine the rate at which a function changes. It tells us the slope of curve at any point. This tool allows us to find the derivative of almost any functions and are useful in science, engineering, or business, where we want to know how fast something is moving or changing. As a final point, knowing how or when to use them in everyday life can be a crucial part of any profession. So, learning early is always a good thing. Thank you.
That's all from us. Bye.